What a pleasure it is to introduce our speaker tonight, Avi Loeb. He's here with deepest thanks to Bob Kirshner, who was one of our distinguished science activity speakers last year. And Bob, when I asked Bob who he might suggest to speak with our group, Bob said, unequivocally, you have to talk to Avi Loeb and have him talk to you. So it's really wonderful to have him here tonight. And I'm so glad Avi accepted our invitation to tell us about his work and especially his investigation of interstellar objects, including the famous Oumuamua, or Scout as it's translated in Hawaiian. And you've read that Avi holds an endowed professorship of science at Harvard, that he is a best-selling author, that he received his PhD in physics when he was 24, that he's led international projects in strategic defense, and is currently searching for extraterrestrial intelligence as head of the Galileo Project. Avi is the director of the Institute for Theory and Computation at the Harvard Smithsonian Center for Astrophysics and the founding director of Harvard's Black Hole Initiative. He's a fellow of the academies and many academies and societies, including the advisory board for Einstein Visualize the Impossible. And I'm going to be first in the Q&A line to ask him about that. Avi is as much a philosopher as a scientist, and his essays speak to his passion in both areas. And I really commend his essays to you. He's a prolific writer and has wonderful things to say. And I asked him to share some personal details with us tonight. So I want you to know that we are privy to information that probably is known nowhere else. And these are some of them. Did you know that Avi grew up on a farm in Israel, and in order to study, he would take his books on the family tractor so he could get some peace and quiet out in the fields? Did you know that he gets up every morning at 5 o'clock and jogs no matter the weather? 5 o'clock. And okay, girls, and the men who are out there, he has a 1,600 calorie a day diet and 800 calories spent eating dark chocolate. I love that. I love that. He's a man after my own heart. So welcome, Avi. We look forward to your talk, and take it away.
By the way, when I'm getting wounded, when I have a cut in my finger, the color of the fluid that comes out is brown because of all the chocolate I ate. The other thing I should say is throughout my life, I was mostly influenced by women. I was very close to my mother. She passed away a few years ago. And I grew up with 2 sisters. I have 2 daughters and a wife. And so, you know, all my problems come from men primarily. So you will hear about some of them today. But I just wanted to tell you how wonderful it is for me to see all of you in the audience. So let me share my screen. And I will present for about, oh, can you see my screen or not yet? Oh, somehow it went away.
It flashed off. Try again.
Okay, let me try again. Can you see my screen now?
Yes.
Okay, perfect. So let me just
actually it's the whole desktop rather than just the slideshow.
Yeah. That's because I haven't pressed the button of the slideshow yet. It will come up in a second. Okay. So what I'll describe today primarily is the content of my book, Extraterrestrial, that came out a year ago. And it was quite an interesting ride because over the past year, I had 2,000 interviews about the book. There was huge interest. It became bestseller in many countries and translated to 25 languages. And if I had to summarize this book in one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. And what you see on the right side is the cover of a textbook that I wrote last year. And that's intended for the scientific community that wants to work on the frontier of the search for life in the universe. It involves both primitive life, microbial life, so biosignatures, as well as intelligent life, technological civilizations, that's called technosignatures. What you see on the left side is a photograph of a picture that was hung on the walls of the Berlin Brandenburg Academy of Arts and Sciences. It was taken by the German photographer Herlinda Quilbel, and she put it there in an exhibit a year and a half ago. And actually now this exhibit is in Baltimore. And the picture that you see is based on a photograph she took in my office. She asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, are we alone? And actually, more importantly, are we the smartest kid on the cosmic block? Now, the one thing we now know that was not known decades ago is that about half of the sun-like stars host a planet roughly the size of the Earth at about the same separation. So that means if you count all the stars in the observable volume of the universe, there are more planets that are habitable, like Earth, than the number of grains of sand on all beaches on Earth. So, not only that we are not at the center of the world, the center of the universe, as a lot of people thought millennia ago, and actually the ancient Greek philosopher Aristotle argued that we are at the center of the universe, and people believed him for 1,000 years, because it flattered their ego. And then when Galileo and Copernicus argued, no, we think that actually the Earth moves around the sun. And Galileo said to philosophers, why don't you look through my telescope and you might be convinced that I'm right? And the philosopher said, no, we know the answer. We know that the Earth is at the center of the world and we don't need to look through a telescope. And they put him in house arrest. Today, they would have canceled him on social media. But if you were to ask those philosophers to design a rocket that would reach Mars, they would always get it wrong because they thought that Mars moves around the Earth. So reality is whatever it is. The Earth continued to move around the sun irrespective of whether it was a popular view at the time. And nobody remembers those philosophers nowadays. But beyond the fact that we are not at the center of the world, moreover, what we find in our backyard, the Earth-Sun system, is not rare. So we are not privileged. And this is the message that we keep hearing back from the universe, that we should be modest. We shouldn't think that we are special, unique. We shouldn't feel that we are the central players on this cosmic stage. It's not about us. Sorry, someone is not muted. Someone is hurt. So, we keep thinking that the play is about us, but we are not at the center of the stage. We just came.
This is it, huh?
Sorry, there is someone that we can hear. If you can mute yourself. Okay. So it's not only that we are not at the center of the stage, but we also joined the play relatively late. Albert Einstein was probably not the smartest scientist that ever lived since the Big Bang, because most stars from billions of years before the sun, there could have been a scientist smarter than Albert Einstein on another planet around another star 1 billion years ago. And when you see a painting of the type shown here of usually an alpha male, an emperor or a king that was very proud of himself after conquering a piece of land on Earth, and today's incarnation is Putin trying to conquer a piece of land, that is quite disappointing because, how can you be proud of yourself if you resemble an ant trying to hug a single grain of sand on the landscape of a huge beach? That's not very impressive. But I can understand where it's coming from, because when my daughters were young and they stayed at home, they thought that they are the smartest in the world and that the world centers on them. And of course, that perception changed when I took them to the kindergarten and they met other kids, some of whom were smarter than they are. So the conclusion from that is that our civilization will mature by meeting others. And, you know, on the first day of my class at Harvard, I told my students that half of them are below the median of the class, because that's the way in statistics that the median is defined, that in any class, half of the students are below the median. That's a statistical fact. But students that come to Harvard are obviously all convinced that they're at the top 1%. So they have a hard time accepting the notion that half of them are below the median. And if I had to guess, I would think that our civilization is sort of in the middle of the bell-shaped curve in the distribution of intelligence civilizations within the Milky Way galaxy. And many of those intelligent civilizations must have existed before us, because most stars formed billions of years before the sun. So time is measured in billions of years in the universe. That's a long time. And such an intelligent civilization could have filled up the entire Milky Way galaxy with probes within a billion years. Even if you send out chemical rockets, they can traverse the Milky Way galaxy many times over in a billion years. And one can imagine sending probes that are equipped with artificial intelligence so that they are autonomous. They don't wait for guidance from the senders because the distance between stars is huge. The nearest star to us is 4 light years away. And it takes tens of thousands of years for light to traverse the entire Milky Way galaxy. So it makes no sense for a probe to wait for guidance from the sender across the Milky Way galaxy. It would make much more sense for it to have artificial intelligence so that it can learn from experience through machine learning and operate on its own. And the question is whether the entire Milky Way galaxy is full of such probes. And that's not a philosophical question. This is a question to which we can find an answer by looking through our telescopes, searching for such, I call them AI astronauts, artificial intelligence astronauts. And we don't want to repeat the mistake that philosophers made 4 centuries ago when they refused to look through Galileo's telescope, arguing that they know the answer in advance. Now, the first object that was discovered from outside the solar system was found by a telescope in Hawaii on Mount Haleakala in Maui on October 19th, 2017. And it was given the name Oumuamua, which means a scout in the Hawaiian language. You can see it here circled in blue and on the background of stars. This object was, at first, astronomers thought, well, it must be a comet. Just like the objects we often see in the solar system, there are rocks surrounded by ice, and the ice evaporates when they come close to the sun. And so you end up with a tail of gas and dust around them. But there was no such tail of gas and dust around this object. It didn't look like a comet. Moreover, it came from a very special frame of reference. Now, we knew that it was not bound to the sun, that it's the first interstellar object because it moved too fast to be bound to the sun. So it clearly came from outside the solar system, but it came from a special frame of reference. It's the so-called local standard of rest. That's the frame that you get to when you average over the random motions of all the stars in the vicinity of the sun. So each star moves in a random direction with some speed, but when you average over the local population of stars, you get to this, you can think of it as the parking lot, the local rest frame. And this object, Oumuamua, was at rest in that frame, sort of like a buoy on the surface of the ocean, and the solar system bumped into it like a giant ship. And only 1 in 500 stars is so much at rest as Oumuamua was in that frame. And the sun gave it a kick as a result of its gravitational force. We discovered it on its way out. We still hear someone. And as the object was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that the object has an extreme shape, most likely pancake-like, based on the variation of light. So you can think of it as a piece of paper tumbling in the wind, and the amount of area that you see from the piece of paper changes by a factor of 10 as it's tumbling. So that's how this object looked like, a flat object with an extreme shape. But there were other anomalies. In addition to what I described, this object deviated from a trajectory that is shaped just by the sun's gravity. There was some mysterious force that was pushing it away from the sun. And since the object was not evaporating, it couldn't be the rocket effect from evaporating gases. And the only sense I could make of it is that the object is getting pushed as a result of the reflection of sunlight off its surface. But in order for that to be effective, the object had to be very thin, sort of like a sail, and nature doesn't make such objects. So I wrote a scientific articles suggesting that it may be artificial in origin. One way to think of it is like a leaflet. So imagine another civilization sending out letters, leaflets, they would behave just like Oumuamua did, because they would be thin and they will be pushed as a result of their large area compared to their mass. But of course, even though the public was extremely interested in this possibility, my colleagues in academia pushed back and argued it must be natural. And so what were the proposals that were made as, for Oumuamua as a natural object? All of them suggested something that we've never seen before. So one proposal was a cloud of dust particles that are very loosely bound, 100 times less dense than air, and sort of fluffy, and as a result of the reflection of sunlight, it gets pushed. The problem with that idea is that such a cloud would get heated by hundreds of degrees when it gets close to the sun, and it would not maintain its integrity because it doesn't have the material strength. Then there was a suggestion, maybe it's a chunk of frozen hydrogen, an iceberg made of pure hydrogen, so that when it evaporates, it behaves like a comet, but we can't see the hydrogen because it's transparent. And the problem with that, well, first of all, we have never seen a chunk of frozen hydrogen in space. We don't know if nature makes such a thing. It has to be the size of a football field in this case. And moreover, we showed in a paper that this iceberg would not survive very long because hydrogen evaporates very quickly. So it couldn't really survive the journey in interstellar space. So then another team suggested, well, maybe it's a chunk of frozen nitrogen that was chipped off the surface of a planet like Pluto. And the problem with that is the mass budget. There is just not enough solid nitrogen available on planets like Pluto to produce a large enough population of chips such that one of them will be detected by the Pan-STARRS telescope in Hawaii. So it's also a very challenging idea that faces problems. And all of these proposals invoked something that we've never seen before. So the fundamental question is, what is the origin of Oumuamua? Is it natural or artificial? Given that the natural proposals invoke something that we've never seen before. And the way I think of this is just like walking on the beach, and most of the time you see rocks that are naturally produced. but every now and then you may see a plastic bottle. And perhaps Oumuamua was a plastic bottle coming from a civilization out there. In September 2020, there was another object discovered by the same telescope in Hawaii, which shared the qualities of Oumuamua. It was given the astronomical name 2020 SO, and it was also pushed away from the sun by reflection of sunlight with no cometary tail. But then a few weeks after it was discovered, the astronomers realized, oh, if you extrapolate the trajectory back in time, it actually came from Earth. It's a rocket booster that was launched by NASA in 1966. And it was hollow, therefore the walls were thin, and it had a large surface area for its mass. That's why it was pushed by reflection of sunlight. And we also know that it was artificial in origin because we produced it. The question is, who produced Oumuamua? And the way I think of that is like a cave dweller finding a cell phone. The caveman is used to playing with rocks all of his life. So he would argue at first that the cell phone is a shiny rock, a rock of a type that he had never seen before. But if he would be curious, he might examine this object and realize that when he presses a button, he can record his voice, and therefore it's not a rock. And think about it, if a caveman were to arrive at New York City and find all the gadgets, the electronic gadgets out there, he would come back to the cave, and this would become a myth, a mythical story to his family. He would not be able to retro-engineer what he finds in the big city. But nevertheless, it's possible for the caveman to conclude that a cell phone is not a rock. And that will only be possible by getting enough evidence on objects like Oumuamua. Because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words. That's the number of words in my book, Extraterrestrial. And I wouldn't need to write the book if we had an image. I just want to know the answer. This question is not philosophical. All you need is to bring a camera close enough to the object to capture its image. And I was surprised there was actually a philosopher that published an article in Nature Astronomy magazine arguing that Oumuamua must be natural based on philosophical reasoning. That was 1.5 years ago. And I thought to myself, how is that possible? That 4 centuries after the experience of the philosophers with Galileo, we still have a leading scientific journal publishing an article by a philosopher who argues that he knows the answer based on philosophical reasoning. The way to find the answer is to get a photograph of the type that you see on the right-hand side. That was obtained by the OSIRIS-REx mission that landed on an asteroid called Bennu. And it didn't only take a photograph that clearly indicates that it's a rock, but it also took a sample, scooped some material from this rock, and it will bring it back to Earth within a year. So there is no doubt that when you land on a rock, it looks like a rock. It's not a philosophical question. And if it looks like a hydrogen iceberg or a nitrogen iceberg, we will know that. All we need is good data. And we did it with this asteroid, so we can do it also with an interstellar object like Oumuamua. And if it looks like it has bolts and screws on it, and there is a button that we can press, I would love to press this button. So about 6 months ago, I established the Galileo Project. A number of multi-billionaires visited the porch of my home, and they were inspired by my book, and they asked me questions, and they ended up donating $2 million to my research fund at Harvard. And that allowed me to establish the Galileo Project. And for obvious reasons, we call it after Galileo, because we want to find the answer by looking through our telescope. And if Galileo Galilei was alive today, I would have admitted him as a honorary member of this project, because we are basically following his footsteps. And one branch of the project is indeed to bring a camera very close to the next Oumuamua, and sort of like going on a date. And we went on a date with Oumuamua, and we sort of were intrigued by it, and we just didn't figure out its nature. So we are trying to date the next Oumuamua, and there should be another one coming. And within a year, there will be a telescope much more sensitive than Pan-STARRS called the Vera Rubin Observatory in Chile that could detect an object like Oumuamua every few months. And if we identify an object like that, we can design a space mission that will come close to it. Now, this space mission will cost $500 million. It's a very expensive date. So one has to be quite selective about the companion that we choose for that date. Now, at the same time, in June 2021, last year, the director of the Office of National Intelligence, Avril Haines, delivered a report to Congress talking about objects within the atmosphere of the Earth whose nature is unclear. And the government has some data on them, but cannot figure out what they are. And so these are called unidentified aerial phenomena. And the head of NASA, when this report came out, said, it's about time that scientists will get engaged with the task of figuring out the nature of these objects. So I immediately contacted his office and I said, I'm here to serve, but I haven't heard back. So I established the Galileo Project that will use telescopes to figure out the nature of these objects, because the sky is not classified, and we can use the scientific method to unravel the nature of these objects. And it's just like a fishing expedition. If all we catch are mundane fish, these are objects that are either natural or they are human-made, so be it. At least we clarify the nature of them and we can move on. So we have no agenda. And the Galileo Project has these two branches of trying to figure out the nature of objects like Oumuamua or these unidentified objects that the government is talking about. And it's important to apply the scientific method to figure out the nature of these objects rather than prejudice, because extraordinary conservatism leads to extraordinary ignorance. And I should say, people often quote Carl Sagan, who said, extraordinary claims require extraordinary evidence. And I disagree with Carl Sagan. I think the correct statement to make is extraordinary evidence requires extraordinary funding, because without funding the search, we would never discover anything. The example that comes to mind is the discovery of gravitational waves about 7 years ago by the LIGO experiment that followed an investment of $1.1 billion by the National Science Foundation. Without that investment, we would never discover gravitational waves. The Large Hadron Collider that cost $10 billion was searching for particles that could make up most of the matter in the universe. It's called the dark matter. We don't know what it is. It's a search in the dark, and we haven't found anything, but we invested $10 billion. So if we were to say extraordinary claims that the dark matter is made of supersymmetric particles, that's an extraordinary claim. And for that, we don't have evidence, therefore we shouldn't build the Large Hadron Collider, then we would never make progress. We did invest $10 billion and we didn't find anything. But we didn't invest anything in the search for equipment from other civilizations. So how can we claim that we don't have evidence? It's a circular argument. Without searching, you will have no evidence. It's just like a fisherman on the beach saying, I don't see any fish, but of course, unless you use a fishing net, you will not catch any fish. And here the fishing net is telescopes. So the point of the Galileo project is that we are actually assembling the necessary instruments on the roof of the Harvard College Observatory for the first telescope system in the coming months, based on the funding that I already have. And that includes infrared cameras, visible light cameras, radio sensors, and audio sensors that will monitor the sky. And then we will also have software that is using artificial intelligence to identify the nature of objects, to tell us whether they are birds, drones, airplanes, or something else. And once this first system will operate the way we want it, we will make copies of it. So with the $2 million that I have, we can at most make about 5 copies and distribute them in various locations. But what we really need is hundreds of copies, and that will cost about $100 million. And so that's the goal. And I'm currently doing my best to convince some wealthy individuals to provide us with the necessary funding. But $100 million is relatively a modest level of funding for a scientific project. It's only 1% of the Large Hadron Collider, or 1% of the James Webb Space Telescope that was recently launched. That's a relatively small investment on a question that is of great interest to the public, to the government, and to the scientific community. So here is an illustration of the system that we will put together on the roof of the Harvard College Observatory. And what you see on the right side is the infrared and visible cameras. And then on the left, you can see the radio sensors and the audio sensor. And this is an illustration of the infrared camera. And the advantage of it is that you can see objects at night in the infrared based on the heat that they emit, whereas the visible light camera that also has a fisheye lens that can look at the entire sky at all times will see objects during daytime. Now, Enrico Fermi, a very famous physicist, about 70 years ago, he had lunch at Los Alamos in the company of his colleagues, and they were discussing extraterrestrials. And at some point he said, well, if it's so likely that there were other civilizations out there, where is everybody? And that became known as Fermi's paradox. But it's actually very presumptuous. It's like sitting at home on the sofa and saying, I don't hear a knock on my door, therefore I don't have neighbors. Well, to find your neighbors, you need to look through your windows. And you better use a telescope if you want to learn about them. So Enrico Fermi didn't use any telescopes. He was hoping that they would land in Los Alamos at the time that he was asking this question. And even if you look at the entire recorded human history, that lasted for 10,000 years. It's about 1/1,000,000th of the age of the Earth. There could have been a visit a long time ago that we haven't witnessed. And it's quite possible that if you're looking for radio signals or other kinds of signals, that these civilizations are short-lived. When they develop their technologies, they also destroy themselves after a while, as we are changing the climate or doing other things, fighting each other. And so perhaps there is a very narrow window, but if those civilizations, before they inflicted the wounds on themselves, if before that they were able to send equipment to space like we did, we sent many spacecraft out of the solar system. If they did that, then we could find evidence for them by finding those instruments that they sent out. And this would be the equivalent of doing archaeology. So looking for radio signals, the way that the search was done in the past 70 years, is just like trying to have a phone conversation. You need the counterpart to be active at the time that you're listening. But objects can last forever in principle. Just think about Voyager, New Horizons. These spacecraft would still be around in 1 billion years from now. They will not be functional. They might be defunct, but just like finding plastic bottles that are punctured on the beach, they will tell a story about the civilization that sent them. So that's the equivalent of doing archaeology, except doing it in space. And it's a new approach to the search that was never practiced. And the Galileo Project is really embarking on that for the first time as a fully fledged scientific project. And my hope is that if we find relics of a smarter kid on our cosmic block, perhaps it would inspire us, because when you look at human history, what you find very often is a group of people trying to feel superior relative to another group of people, and that brings a lot of distraction. And the best example is the Second World War, where the Nazi regime led to the killing of 75 million people worldwide. That was 3% of the world population in 1940. And just think about the number. It's 10 times more than the number of deaths triggered by COVID-19 in the past 2 years. And we've been talking about it forever. So just because a group of people decided to feel superior, they triggered the death of 10 times more people around them. And my hope is that if we find a more intelligent civilization far away, that would imply that the differences among us as humans are insignificant. There is a much smarter kid on our block. And perhaps that would encourage us to treat each other as equal members of the human species. Thank you. I'll be glad to answer any questions. You can unmute yourself now.
I have unmuted. Yes, thank you. Sorry.
I have a
Well,
question.
Go ahead, dear.
Go ahead. Don't worry about the order. I will answer all the questions. So please start. Yes, go ahead, Jerry.
How can you tell what is not natural and what is artificial?
That's an excellent question. So I'll give you an example. When you get a high resolution image and it shows bolts or screws on an object that seems to be manufactured in a way that nature never makes, that will convince me at least that it's artificial. Now, it may well be, I mean, it all depends on the technological gap between the device that you find and what we can produce, because it might look like magic to us what this object can do. But I don't care about us reverse engineering it and understanding how it works. You know, it might, the gap for that might be too big. We won't be able to understand, just like a cave dweller cannot understand how an iPhone works, okay? We might be in that situation, but that doesn't really matter, because all we need to do is rule out two things. One, rule out that this object is natural because it doesn't look like a rock, doesn't look like a bird, doesn't look like a phenomenon in the atmosphere of the Earth. It's a real object. Suppose we land on it and it's made in a way that is not natural, that looks artificial. It was manufactured. You know, nature doesn't make such things, okay? So that's the first thing. And the second thing we need to make sure is that it's not produced by the Russians or the Chinese or any other nation on Earth. Okay, so it's not human-made. And again, if that is easy to tell, because we pretty much, well, first of all, the US leads the way in technology, so we pretty much know what we are producing. But at the same time, we know what other nations are producing, because we have spies, and also because if they have an edge relative to us, we would see it in the commercial sector, or we would see it somewhere in the battlefield. So we can pretty much tell what human technology can accomplish. And if we see something that does things well beyond that, we would know that it's not human made, okay? And moreover, if it comes from outside the solar system, it cannot be human-made. So if we see an object moving too fast to be bound to the sun, you know, that is coming from a random direction, it just cannot be an object that was produced on Earth. And once we ruled out both of these possibilities, that it's not natural and it's not human-made, as Sherlock Holmes said, whatever remains, however improbable, must be the truth. That's the way science is done, you know, you just eliminate possibilities. Now, of course, many of my colleagues have a problem even considering the possibility that it's artificial, that Oumuamua is artificial. And there are two reasons for the fact that there is a pushback to the possibility of considering an extraterrestrial technological origin for Oumuamua. One is that experts prefer to always be able to maintain their image and tell that they can figure out anything we find on the sky based on what they already know. So if they studied rocks for decades, they would say anything we find on the sky is rocks, you know, and that's, to me, just like the caveman finding a cell phone. Now, the point is, they would keep arguing that it's a rock of a type that we've never seen before, but it's still natural. You know, that is, to me, quite surprising. How can they be confident of something we've never seen before, like a nitrogen iceberg, a hydrogen iceberg? And we don't know that such things exist. We don't know the environments that produce them, and they need to be quite common, because we saw the first object coming from interstellar space to be so weird. Okay, so it must be common. And so my point is, we should be more open-minded. Now, the second reason that many scientists have a problem discussing it is because, you know, it, of course, threatens our ego. The Perseverance rover is a robot on the surface of Mars looking for primitive life that may have existed on Mars early on, and it's being operated by engineers in a Jet Propulsion Lab in Pasadena. And of course, if we find microbes, our ego will not be threatened because, you know, we are much more intelligent relative to those microbes. So we can still feel good about ourselves. But imagine the same Perseverance rover bumping into the wreckage of a spaceship that represents a technology far more advanced than we can possess. That would be a blow to our ego. And a lot of people prefer not to recognize that possibility. And then finally, there is this aspect that the public is so interested in this that many people in academia prefer to distance themselves from the public. They prefer to ask questions like, how many angels can sit on the tip of a pin and do mathematical gymnastics just showing that they are smart, so that the public will never understand what they are doing. Okay, that puts them on a pedestal. And if that's your ambition, then I would argue that you're not a real scientist, because science is all about figuring out reality. And if the public cares about a question, then scientists should attend to that question. Just like when COVID-19 appeared, you know, that was a major issue that is of importance to society, and scientists were engaged. And that's really important, to serve society and try to explain things.
In the Galileo Project, I mean, or are you looking specifically just for those people with lots and lots of money who can make it happen a lot faster?
No. So the project is international, and Nancy, we cannot speak because of.
I'm sorry.
The project includes scientists from many different nations, so it's international, just like any other scientific project. And in terms of the funding, you know, that can come from anywhere in the globe. You know, it's a scientific project. The data will be open, available to the scientific community. And, you know, science has no borders because it's not a matter of national security. It's an international matter, whether we are alone or, you know, whatever we find, whatever knowledge we have as a result of getting the evidence, the data will be shared by all humans, irrespective of national borders. So in a way, it's a standard scientific project that we hope to get funded. And anywhere, if there is anyone from any nation, we will be happy to speak with them as being partners in this project.
Thank you for that. You also had, I'm sort of looking at the time, and does anybody have any questions?
Yeah,
pertaining
I see Susan
Galileo?
Susan raises her hand. Go ahead, Susan.
Yes, I'm wondering if the James Webb Telescope will allow better imaging. You seem to be using earthbound telescopes, but you have the atmosphere.
Right, that's an excellent point. And indeed, the JWST, the James Webb Space Telescope, they could potentially look at the next Oumuamua and get much better data about it. So for example, we would like to know what it's made of. So if we take a spectrum of the object, or the reflection of sunlight, or if there is any evaporation or anything around it, we could learn a lot about it before we come close to it, before we send that camera to within 1,000 kilometers from it, so we can learn more about it. Yes, so the answer is definitely yes. The James Webb Space Telescope is a 6.5-meter telescope. It's a huge space telescope that we've never had before. The Hubble Space Telescope was 3 times smaller. So we can learn much more with it about the future objects that are as anomalous as Oumuamua was, definitely, yes.
And Oumuamua was interesting because its shape was very unnatural.
No, so there were several anomalies. I mentioned them briefly. One of them is that as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. So that meant an extreme shape. It was at least 10 times longer than it is wide, but then it was also pushed away from the sun by reflecting sunlight. And for that, it had to be very thin. So that made it quite unusual that there was this force acting on it, even though there was no cometary evaporation. So it couldn't be the rocket effect from evaporating gases. And then it came from this special frame of reference, the local standard of rest, which only 1 in 500 stars is so much at rest in that frame as Oumuamua was. So it couldn't have originated from any of the nearby stars. And it was rare in that regard as well. And so I talk about all these anomalies in my book, Extraterrestrial, and you're welcome to have a look at more details. But basically, it didn't look like either a comet or an asteroid of the type that we had seen before in the solar system. It looked really weird. And that was the first interstellar object that we discovered. The second one appeared just like a comet. So people came to me and said, well, doesn't it convince you that Oumuamua is also natural? And my answer was that, you know, if you walk on the beach and you find a plastic bottle, and then after that you find a rock, it doesn't make the plastic bottle a rock. In fact, it makes the plastic bottle more unique because it looked very different.
I want to know what you think about when you're running at 5 in the morning.
Oh, everything that happened the previous day. And I often come up with good ideas for my next commentary or my next scientific paper. And I really love nature because it's a relaxing experience. You know, every morning the sunrise looks different. And if it snows, like last night it snowed, and it really looks beautiful. And I was born on a farm, and I connect to nature much more than to people. I'm not a social person. I have no footprint on social media. I don't care how many likes I have on Twitter. As a scientist, I'm just trying to advocate for what I think is right. And, you know, that's why I got attention, because some of the views that I expressed, you know, were sort of original in a way. But in general, I connect to nature much more than to people. And my hope is, you know, really to encourage innovation in science. Young people should not feel afraid of expressing themselves. And that's why I'm trying to argue that we should not all walk on the beaten path. You know, Robert Frost wrote this poem that he took the road not taken, and that made all the difference for him. And for me, taking the road not taken offers the advantage of finding some low-hanging fruit, because nobody took that path, and we might find something really unusual. And you know, so at any event, on my morning jog, I often think about new ideas, and I enjoy nature very much.
Does anyone else have any questions?
Linda, there are a number of questions in the chat we'd love to have the answer to.
I know, and I can't, I've been trying to, oh, there we go. Who has, Eve Masonic? Chris, what about, so Avi, what about radio signals coming from space? What do you think about those listening projects?
Yeah, so as I said, I think for 70 years, we've been looking for radio signals, and that was a misguided approach because it's just like trying to have a phone conversation. You need the counterpart to be active at the time that you're listening. And it's, we've been broadcasting in the radio only for 126 years, since the days of Guglielmo Marconi, and that's a small fraction of the age of the Earth. So there may be a window of opportunity, but it may be quite narrow. But if you're searching for objects, you can find objects even if the senders are not alive anymore. The one thing I find at Harvard when I go to University Hall is all these paintings and sculptures that were left by past presidents and deans that wanted to leave a copy of their physical appearance out there so that people will remember them. But that makes very little sense for an astronomer because, within 1 billion years, the sun will get so hot that it will burn up everything on the surface of Earth. So if you wanted to leave something from you for the very long term, you would send it to space. You would send monuments to space in the form of, AI systems, for example, that carry your blueprint. And that's a much better approach. The other comment I would make is that even when sending equipment to space, we didn't show a lot of intelligence. There was the New Horizons mission to Pluto. And on the mission, NASA put a box with 30 grams of the ashes of Clyde Tombaugh, the person who discovered, the scientist who discovered Pluto. And I'm really embarrassed by this because, what are ashes? Ashes are burnt up DNA. You take the genetic information about a person and you burn it, you destroy it, and you put it in a box. And these ashes are no different than the ashes of a cigarette. So then if an extraterrestrial finds them, it would be very embarrassing because they would say, these humans have primitive rituals of destroying the information about the person that they want to commemorate. So I actually asked the principal investigator of the New Horizons mission, I said, why didn't you put a stem cell from Clyde Tombaugh's body that at least they would be able to reconstruct that person when they find him, the stem cell. And he said, it would have been a bureaucratic nightmare for this to be approved within NASA. So the conclusion from that for me is that the most sophisticated equipment that we will find in space would be coming from civilizations that have the least bureaucracy. But if we ever want to correct that mistake of sending this box with ashes, we should send another spacecraft that goes faster than New Horizons and apologizes for the box behind it. Any other? I see other questions, so let me answer them very quickly on the chat. Will light and sound pollution, that's Betsy, will light and sound pollution in Boston affect your research? Okay, so the system we have in Boston is not really intended to discover new things. We're just testing the system and then we'll put it in a much better location. And then
Eve Masonic, there may be possible dangers of pathogens. What steps are we taking, presuming that we are looking at an object that will reach our universe? So she's a little bit worried about interstellar pathogens, it looks like.
Oh, okay. I think it's very unlikely that if we find an object that it will carry any biological material, because the journey takes hundreds of millions of years between stars across the Milky Way galaxy. So nothing biological can survive for that long. The conditions in space are very harsh. You know, we were selected by Darwinian evolution to survive on the surface of Earth, and human astronauts cannot survive in free space for more than a year or a few years. That's why I have a problem with these ideas that Elon Musk and Jeff Bezos are advocating for sending humans to space. And actually, I was in a forum with Jeff Bezos at the Washington National Cathedral, where he was arguing that in the future we'll have 1 trillion people in space and Earth will be regarded like a national park that you come and visit every now and then. And I think that makes very little sense, because humans will not survive. It's not easy to protect humans in space, and we didn't evolve to survive in space. And it makes much more sense to send technological equipment to space in the form of AI astronauts that I was talking about before. They can survive for billions of years in space. And I'm actually, frankly, I'm very proud of our technological kids. I don't feel we need to send these human bodies which are really sluggish, not optimized. AI astronauts could be operate much more intelligently, learn much faster, process much more data. You know, I'm very proud of AI systems. There is no need to send humans to space in large quantities, and because that, you know, that could bring them to their death very quickly. I know that a lot of people would be happy to go there, but they won't survive very long. And the other thing about that I should mention is William Shatner approached me to have an interview. And so I told him, you know, the one thing that I don't like about the current discussions about the metaverse, you know, these virtual realities, is that, you know, as a scientist, I really enjoy the reality we live in, learning about it, rather than, you know, putting goggles on your head and imagining things that do not exist. And that's why I don't like science fiction, because it's a virtual reality. It's not the actual reality. So I said to William Shatner, who played Captain Kirk in USS Enterprise on Star Trek, I said to him, well, you lived in a virtual reality as an actor in Star Trek for many years. And then last year you flew into space in reality, the actual reality. So it's probably clear to you that the experience is very different. And he said, yes, I completely agree with you.
Anyone else? Anyone else? I want to give everybody a chance. I see a business, Avi, in developing in rockets full of people being launched into space to circle in the universe forever instead of being buried.
Oh, no, I don't see a business in that. I see a business in something else, actually.
I can see statues and paintings going off into the universe so that they'll be recognized at some point.
Okay, so first of all, I should say, when Jeff Bezos was speaking at the Washington National Cathedral, I thought to myself, okay, you know, you can dream about space tourism and, you know, sending people a little bit above the Earth, 1% of the Earth radius, like they were doing last summer. But there is no business plan for leaving the solar system. You know, you can't make money out of that. The only reason we would leave the solar system would be spiritual, trying to discover the unknown, okay? And I think that's a much more admirable notion of, you know, going to space than trying to make money out of it, or trying to demonstrate that we are powerful, that we can go 1% above the Earth radius. You know, that's not very impressive. And showing off in space is an oxymoron. We should go into space with a sense of modesty. And we should send our technological kids to space. Now, I actually am starting together with a colleague of mine, a very wealthy individual. We're starting a corporation that will be based on some of the ideas I mentioned today. And I don't believe in large communities of people on Mars or on the moon. I think we should let our technological kids lead the way.
Well, I know that our ARCS scholars, the wonderful ARC scholars that all of our chapters support around the United States, many of whom are studying physics, astrophysics, and just we are so proud of them for all that they're doing. We're so proud of their youth, their enthusiasm. I'm sure you see that at Harvard, but it just gives us great, great pride.
Well, Oscar Wilde coined it very nicely more than a century ago. He said, "We are all in the gutter, but some of us are looking at the stars."
Well, I think that is very well put, and that brings us to a wonderful conclusion. So all of us we have to go outside tonight and look up and think of Avi and all of his research, and take a look at that big picture, because the one here on Earth at this moment isn't the most optimistic. So I think looking at the stars sounds like a pretty good idea.
Yeah, one reason I search for intelligence in space is I don't often find it here on Earth. And, you know, the latest war is an illustration of that.
Thank you, Avi, so much. Really, what a joy. Thank you. Oh, what kind of chocolate do you like?
Between 80% and 100% dark.
I'm going to ask Bob Kirshner for your address. You shall get some. Thank you so much.
Thank you.
Thank you. Excellent.
Big, wild applause.
I appreciate it. Bye-bye.
Night.